Okay, today we're going to continue on with this hypothetical problem that we're trying to model, where we're trying to model the surgical apparatus here for this surgical rod that's holding back part of the tissue, allowing the surgeon to perform a surgery inside the surgical site. So again, oftentimes these apparatuses are used in surgical procedures where the rod would be attached or fixed to the table, and then the rod would be extended with this retractor and used to hold back some tissue. And what we're trying to do, what we're trying to model here is how long can this rod be without bending too much. And so just for the sake of this example, what we're going to do is try to model this rod and put a 30 Newton load on the end of it and see at what point does it bend more than 1 millimeter, let's say. Okay, and how long can the rod be? Okay, so in the last class, to simplify this model and draw up the geometry, and then we'll continue from there on how to set up a parametric sweep, how to plot the data, and how to make an animation of the results. Okay, so I'll go ahead and open up the console. And we can see that the minimum displacement's occurring over here, 0, and that's should be as we expected, because this part we made fixed to the table, so it shouldn't be moving. This is part of our fixed constraint. On this side over here, it shows that the rod, when it is I made this 150 millimeters long, it will bend 0.6 millimeters. We could make this rod longer, right? So how do we go about setting up a model that could give us the results at multiple different lengths for the rod? Well, we do that with something called a parametric sweep, okay? And so let me show you how to set up a parametric sweep, okay? So before we do that, we're first going to set up a definition, okay? So I'm going to right-click on Global Definition, and I'm going to add a parameter. And for the parameter name, I'll call it rod 1 underscore length. Okay, and I'll make it 50 millimeters for now. Actually, let's just set it at 100 millimeters. Okay, and if I press enter, it'll add the value there. Okay, and so now I've added it as a parameter. The length of this rod, I'll call this rod number 1. The length of this rod is, I want to call it rod 1, okay? So over here where we did cylinder 1, okay, if I click on cylinder 1 and build selected, okay, this is the rod 1. Instead of the height being 150 millimeters, I want it to be rod 1 underscore length. Okay, and then I can click on build selected, and notice it built. It made this rod now 100 millimeters. Okay, because we defined that parameter as 100 millimeters. Okay, and I'll just say build all. Okay, so it builds everything back. Okay, and then I come here to the study, Okay, everything else stays the same. We can double check it too. Take a look at our materials. If we click on our materials, we'll see that the material properties are still being applied to all the domains. If I take a look at my solid mechanics, my fixed constraint is still applied here, and the boundary load is still applied there. Okay, and the mesh I think we'll have to build over again, so I'll just click Build All. And in the study, again, what we want to do this time is we want it to compute for several different lengths of the rod. And we want the rod to get longer, and we want to look at the results and see at what point will the total displacement of the tip of the rod exceed 1 millimeter. So to do that, we're going to do something called a parametric sweep. So I'm going to right click on study 1, and I'm going to click on add a parametric sweep. Okay, and because we've already defined it as a parameter up here, we can click on this plus button to add a parameter. Okay, and it will, if we had more parameters there, we could use this drop down box and add more parameters, but we only have one in this case. And for the value of this parameter, I'll click here, and for the value of the parameter I want to set up a range. So I click on range. Okay, and I want it to start, let's have it start at 50 millimeters. Again, units have to be in brackets. And let's have it grow in increments of 10 millimeters. And then let's have it grow to a length of 200 millimeters. And let's see how much displacement occurs for each one of these steps. So if I click add, it'll add it to this section here. Or if I already have a range typed in there, I can press replace and it will replace it. In this case I have nothing there, so I'll just click add, and notice it adds the range. So again, it's going to compute the results starting with this rod being 50 millimeters long, and then growing in increments of 10 all the way to 200 millimeters. Okay, so that's how I set up the parametric sweep. And then if I right click on study 1, I can press compute, and it will compute. And notice the progress bar in the lower right hand corner. And you know what, let me cancel it real quick. I'm just going to press cancel. I'm aborting that because I wanted to point out, notice how it was computing but it wasn't showing us any results. That's because in the parametric sweep I forgot to click on this plot. Okay, so I want to click on this plot, okay, so that it outputs the results while solving. Okay, and that's important because if you made a mistake and you don't want to wait for it to have finished computing all the results for you to realize you made a mistake. So sometimes it's helpful if you can watch it as it's computing. So I go ahead and click on this plot, okay, and then come back here to right click on study and press compute. Okay, and now notice the green progress bar is progressing, but here it's updated the geometry to show the rod being 50 millimeters long and growing by increments of 10 and updating the results as the rod gets longer. Again, we set up the rod length to go from 50 millimeters all the way to 200 millimeters. And notice it's showing the maximum displacement. And we'll let this continue to run. Okay, so it finished running, and the default is to show, notice it added a 3D plot group down here. This was the old one. So this is the new 3D plot group. Again, deformation is overlapped on there. And let me just show you, it adds this deformation by default, but I can show you how it does it. So I'm just going to right click and delete it right now. I'll say yes. And notice how the deformation is now gone. Now it's only showing the von Mises stress. Okay, well, you can add the deformation by right-clicking. Right-click on the surface, okay, and add this Add Deformation, and it's going to add the deformation here in meters, it looks like, and here's the scale factor, so so we can see it. And I'll go ahead and press plot. It already plotted it, and here you can see with the old wireframe where it was, and you can see it like bending. Okay. All right. So this is again just plotting the von Mises stress, and we can also add the max and min surface plot to show the maximum displacement. And let's have that be in millimeters. I'll press plot. And so again, I see that the minimum displacement is occurring over here where I expect it to be fixed to the table, and the maximum displacement when this rod is at 70 millimeters or 0.07 meters. The maximum displacement on the end of the rod here would be 0.18. Okay, so let's take a look at some of the other steps. If I come up here to the parent, and again it's plotting from solution 2. Okay. And if I want to look at any of the other steps, let's say when it's 150, I just have to select 150 or 0.15 meters, press plot, and then it'll show the results there. And I can look at all the different results. Let's take a look at the results at 0.2 meters, which is 200 millimeters. Update the results, and look here, I can see it. The displacement exceeded that 1 millimeter limit that we wanted to set. So let's take a look at how we would plot this data and look at the results on a graph. So to plot this data, I'm going to right click on results, and I'm going to add a 1D plot group. Okay, so here sets up my 1D plot group. And I want this data to come from solution 2. Solution 1 was the first time we ran it. Solution 2 is with the parametric sweep. And for the parametric sweep, I want it to give all the data. Okay, I want it to give all the data. So I leave it like that. And I right click on this 1D plot group, and I want to add a point graph. So the difference between a point graph and a line graph, don't get these confused. This is where the data is coming from. We want the data to come from a point on the part, not from a line on the part. So because we want it to come from the tip, which is a point on the part, we'll click on this point graph. So again, the data will come from a point, and we have to tell it from which point. So I'm going to zoom in on the tip here, and I'll select one of these dots. I'll select this point. Might have to zoom in a little bit more. Okay, and you'll see it show up here, and it'll turn blue. So this is where the data is going to come from this point. Okay, and the data it'll show is the displacement in the y-axis, and it'll just, the default is in meters, so I'll change that to millimeters. Okay, and let's go ahead and take a look at this this plot. So I'll click on plot, and there we go. So the bottom here is the rod length, and so the x-axis is the rod length, the y-axis is the displacement of that point on the rod, and we can see the data, how much displacement is happening as the rod gets longer. So here we are, we're graphing the data. Now the x-axis right now is showing me it in meters. I want to change this to millimeters. So to do that, I come down here to the x-axis, and instead of the parameter value, I'm going to down click on this here and press expression. Okay, and in the expression, I want to replace the expression here by clicking on this section here, and I want it to be the rod length. Remember, I want it to be the parameter that we set up. So I'll set it like that. I'll double click, and now I can change the units here. I can make the units in millimeters, and I can press plot to update the plot. And oh, I need to click on this. Notice it changed the units. Okay, so now we're displaying the units in millimeters. This is from the rod growing from 50 millimeters all the way to 200 millimeters. And if I want to have a description of my x-axis, I need to check this x-axis description and press plot. Let's write a description in there. So this is going to be the rod length, and the units are going to be in millimeters. So I just manually type in, label my axis, and then press plot, and then it'll have it there. It looks like by default it already had the units, so I'll just backspace and remove the units there. Okay, so from this graph we can see that as this rod gets longer, okay, the displacement or how much the rod bends, okay, and the question that we were trying to ask was, at what point will it bend too much? And we defined too much as if the tip of the rod bends more than 1 millimeter, then we don't want the rod to get any longer. So at what point is that happening? Well, if you look at the displacement and you go up to 1 millimeter and follow it over, okay, you'll see that the rod length is approximately 190. If you go beyond make the rod length beyond 190 millimeters, you'll get more than 1 millimeter of deflection. Okay, and that's what this model. Well, that's the question we were trying to answer in this model. Let me show you one last thing. Let me show you how to create an animation. So if I go to export and right click and I add an animation, okay, and over here I'm going to click on zoom extents so it zooms out, okay, and actually I'm not going to add the animation. Let me delete that. I wanted to click on the other one. I want to add a player. So I right click on export and I add a player, okay, and then I just go ahead and click generate frames, and it's going to generate frames. Let's see. Oh, we need this to come from this graph. Okay, this 3D plot group, and I'll go ahead and click on that. It's going to come from all the stored solutions for that parametric sweep. Notice, so this is the first frame at 50 millimeters, and then it'll generate, it generated all of them actually. we can play it by clicking on this play button, and it'll play the animation as that rod gets longer. And I can make it repeat by clicking this repeat button here and just press play, and I can visualize the results. So again, this model is trying to tell us how long can the rod get before the tip of the rod bends more than 1 millimeter, and from here you can see that happening.